Hi class, welcome to our lesson in General Chemistry 2. Today we'll be discussing the last part of Lesson 7, which is Lesson 7.3, and we'll just be wrapping it up with our discussion on what actually is collision theory. We're going to talk a lot about collision, the atoms colliding in order for a reaction to proceed, as well as we've talked about catalyst, and we'll be expounding our knowledge more about catalyst today. So this is going to be, I hope, an easy lesson after all the computations we've done so far. So let's begin our class or this lesson by understanding the goals of today's lesson. First is finally understand ano ba yung zero, first, and second order reaction. So we've talked about how to actually find those, how to find the M and the N, and how to identify the order of the reaction. Basically, the order of the reaction for the overall order of the reaction is by adding both M and N. And then there's an order of reaction for a specific substance. For example, an order of reaction for the substance raised by M, and there's another order of reaction by the substance raised by N. So ano ba talaga yung ibig sabihin ng mga number na rin-raise natin? And what are they? Also is for us to be able to explain reactions qualitatively in terms of molecular collisions. So far, we've done this naman. We've discussed how collisions affect the rate of the reaction and how the reaction proceeds by the molecules or atoms colliding. Also, for us to be able to explain the activation energy. So we've tackled a little bit about the activation energy, more specifically when we were discussing about catalyst. The catalyst, what it does is it lowers the activation energy. But the question that we haven't really answered is ano ba yung activation energy? So today we'll be discussing what is activation energy and how catalyst actually truly affects the activation energy. And lastly is for us to be able to identify some different types of catalysts. So there are two categories or two types of catalysts that we are talking about today. Let's begin by understanding the order of reaction. So if you guys remember from our previous discussion, let me just use my pen here. We have learned of the equation, the rate law. Rate law is a mathematical expression that relates the relationship between the rate and the concentration of a reaction. So if you have a substance A raised to some M, forgot the rate constant. So rate constant is in front, some rate constant multiplied by the molarity of substance A raised by M, and another substance, most specifically A and B, are your reactants. And the order of reaction we've mentioned comes from M and N. That was in the module. I don't think we haven't fully discussed it yet, but those that's in the module. I hope you guys remember that. And when we talk about the overall reaction, we usually just have to add M and N. So if that's 1 and 1, then we have overall is equals to 2, meaning the overall order of the reaction would be in the second order. And then what that also means is that it's in the first order for A and it's in the first order for B. So that is, if going back, sabi ko lang kanina, ulitin ko, is for example, yung M natin is 1 and yung N natin is 1. Ibig sabihin yung order of reaction natin for A is in the first order. Yung order of reaction natin for B is in the first order. And then the overall reaction is basically add the values of M and N, which gives us 2 in this type of example. And this will mean the overall reaction is in the second order. So ano ba ibig sabihin ng mga to? Ano ba ibig sabihin ng first order? Ano ba ibig sabihin ng second order? So, like I mentioned, these are actually the mathematical dependence between the rate and the concentration, the molar concentration of reactant. So that means is if you have a zero order, meaning if M and N are both 0, therefore your overall reaction is 0. What that means is that the reaction has a constant rate Kasi minimeasure natin sa or rate law is the rate, tama? Ibig sabihin yung reaction kapag zero order siya, yung overall this is overall na. If the overall reaction order is zero, it has a constant rate that is equal to the rate constant. So ibig sabihin, basically for rate order reaction is rate is equals to K. So ibig sabihin ng zero order reaction in simple terms is that it doesn't matter kung gaano kalaki or gaano karami or kaliit yung concentration, yung molar concentration ng mga reactants mo. It will not affect how fast the reaction will proceed. And we can see that from our, you know, from our own equation, rate is equals to some k. This is the rate law. We've discussed about rate law. We have rate is equals to some constant k, and then you have call this the molar concentration of your reactant raised to zero. And if you guys remember in your algebra or in your algebra, any number raised to zero is equals to 1. Any number raised to zero will always be equal to 1. So if you have a certain concentration of your reactant A raised to 0, that will basically be equal to K times 1. Therefore, your rate is equals to 1. So if you are solving for the rate law and you found out that your M and your N are 0, it means the overall reaction is only affected, yung rate ng overall reaction nyo is only affected by the K. So that's what zero order reaction means. How about the first order? First order reaction, the rate doubles when the concentration of a reactant doubles. So ibig sabihin, there's a direct proportion between the rate and the concentration of your reactant. Okay, what that means is the rate increases in the same order as the concentration of reactants. So let's go back here. This is your rate law. Rate is equals to some constant K multiplied by a molar concentration of your reactant raised to 1. Any number raised to 1 is equals to that number. So ibig sabihin lang nito, your rate is proportion. So that's kind of like a symbol for direct proportion, is directly proportional to your K. What that means is if I raise my K, ang rate ko tataas din siya. If I lower my K, or if I lower my, this is supposed to be A, sorry, it's supposed to be a reactant. If I lower the concentration of my reactant, the rate will also lower. What that simply means as well is, let's just remove this. If I double my concentration, the concentration of my reactant, I double it times 2, my rate would also double. So that's basically what first order reaction is. The rate doubles when the concentration of reactant doubles. If the concentration of my reactant triples, the rate might triples. That is in the first order. So that's what basically first order means. So sinusolve natin yung M or yung N para malaman natin yung order ng substance na yun at what order yung reaction niya to identify how it actually affects yung rate. So doon nanggagaling yung mathematical dependence. And lastly, meron tayong second order. Actually, we have a lot of orders. We have fourth order, third order, pero those are more complicated. We're just sticking to these first three orders that are easier to understand. As for second order, wherein you raise your quantity raised to 2, increasing the reactant's concentration twice as much, twice as much, quadruples the original reaction rate. So ibig sabihin, if my concentration, so this is your concentration, if I doubles it, so if my reactants to raise my, increasing my reactant twice, ang nangyayari sa rate mo, it actually becomes quadruple. Bakit kaya? So going back to the rate law, rate is equals to K, is equals to the concentration of A raised to 2. Familiar naman kayo sa second power, tama? So, yung proportion ng rate ko is basically directly proportional siya sa A raised to 2. So for example, if my A is equals to 2, ang magiging rate ko is 2 raised to 2, that's 4. Let's say if I double my concentration, let's say if I have a concentration of 4, 4 raised to the second power is basically 16. So nangyayari, it quadruples yung value ng concentration. So 2 times, not quadruples, it erases it to the second power. So it's basically, it multiplies it twice as much dun sa concentration ng reaction. So ganun lang yung ibig sabihin ng second order reaction. Last lang, if you have a concentration of 3 molar as your concentration of your reactant, ang magiging rate mo is about 9. So kind of like 9 molar per second. Of course, this is just a proportion na hindi talaga ito yung sagot kasi you still have your K. So that's about K3, or that's K4, that's K2. Pero in overall, that's how it affects the order of the reaction. So yeah, second order, first order, or zero order reaction. So I hope that's clear. So that's all about order of reactions. Now let's talk about the collision theory. We've discussed a lot about the collision theory and how it is necessary for the atoms or the substances, especially specifically your reactants, to collide in order for a reaction to proceed. Unless the atoms collide and collide in a way that is in a proper orientation and hit each other hard enough, a reaction will not proceed. That is because it is based on the following postulates. The rate of a reaction is proportional to the rate of the reactant collision. So, ibig sabihin, yung bilis ng reactant mo, kung gaano kabilis yung process ng reaction mo, depende siya sa the number of collisions. Ibig sabihin, mas marami yung number of collisions in lesser time, mas mabilis yung reactant mo. Kung konti lang yung number of collisions mo sa mahabang panahon, over a longer period of time, mas babagal yung rate of reaction mo. So, ganun lang yun. Yung reaction rate, depende siya sa kung gaano karami yung collision mo at kung gaano karami over a period of time. So, more collisions over a shorter time, so mas maliit yung denominator, mas mataas yung numerator, tataas yung reaction rate. Kung mas konti yung collision mo, tapos mahaba yung time, mas mataas yung denominator kaysa sa numerator, mas babagal yung reaction rate mo. So that's the first postulate. The second postulate is the reacting species must collide in an orientation that allows contact between the atoms that will become bonded together in the product. So mamaya I will show you. Let's go first to the third postulate natin. So third postulate, it says that the collision must occur with adequate energy to permit mutual penetration of the reacting species valence shells so that the electrons can rearrange and form new bonds. So that's kind of like wordy. Let's just break it down. Start our pen. Okay, so when we talk about valence shell, valence electrons are basically the electrons on the outermost shell of your atoms. You guys remember, for example, if you look at your element's age, and the valence shell of element H is actually there's only one electron in its outer shell, as compared to, for example, you have carbon. Carbon has 4 electrons on its outermost shell. And this type of electrons, or yung outermost shell, the electrons on the outermost shells, or the valence electrons, valence shell is the outermost shell ng atoms mo. Ito yung actually nag-combine para makagawa ka ng molecule. So let's look at, for example, you have oxygen. Oxygen has a valence electron of 6. Gusto kasi ng mga electron is they will always have an electron of 2 or 8. Most specifically, kapag mas malaki yung shell niya, gusto niya at least meron siyang 8 electrons sa outer shell niya. So in order to fulfill that, ang gagawin niya is it will combine with the other molecule. Let's remove this. Let's move our own dito. Okay. So, ang oxygen natin, it has 6 electrons in its outermost shell. Uh, Kaya kapag it combines with creating H2O, H nabanggit ko kanina, meron siyang isang electron sa kanyang outermost shell. That's why when they combine, these electrons would actually combine. Yung dalawang electrons na to, they would share these electrons. So, ang mangyayari, yung H magkakaroon siya ng dalawang electron that would satisfy the outer shell ng valence niya. Same thing here. And for O, dahil mas malaki yung valence shell niya, it will have 8 electrons. 1, 2, 3, 4, 5, 6, 7, and 8. So they were sharing electrons. It will satisfy. Therefore, mas magiging comfortable siya. Kumbaga, it will require less energy to stabilize yung valence niya. Kaya yung H2O, yung shape niya is bent dahil sa reason nito. Moreover, also, kaya medyo stable, kaya stable yung H2O molecule because it satisfies the valence need of the hydrogen and the valence needs of the oxygen. So why is that necessary? For the reason na you have to collide at the proper orientation. So yung orientation mo tama. At the same time, yung kapag nagbanggaan yung O and oxygen, kailangan it will have enough force na magdikit para mag-combine yung dalawang electrons na to. Otherwise, kung hindi proper yung orientation niya at hindi sila nag-hit ng enough force, these two will not combine. Nakita natin yan sa example na to. So, for example, you have CO plus O2. This is the reaction. And you are creating CO2 plus oxygen. So, in order for you to create CO2, ang shape ng CO2 is something like this. Ang shape ng CO is something like this. So you have 1, 2, 3. Okay. So, kung ang nagbabanggaan is yung oxygen at yung oxygen doon, this will not create a reaction kasi it's not in the proper orientation. So, kailangan yung O, ang babanggain niya is yung C, yung carbon, in order for you to proceed to this type of shape and to this type of molecule. So, yun yung importance ng proper orientation. And again, it needs to occur at the adequate energy. It means it has to bump it to each other hard enough na yung valence electron nung O nito at yung C is mag-combine sila to create this, to create that combination ng electrons. So that is what collision theory is. And it's actually a little more complicated than that. Bago siya mag-proceed from CO to CO, kasi pinag-a-add mo ito, di ba? Bago mag-proceed, yung dalawang reactants na to papunta dito, this two has to break first. And in order, bago nila mag-break yan, it has to go in what we call an activated complex. An activated complex is basically a transition state. It's a shape na gagawin ng dalawang reactant bago sila mag-decay papunta sa dalawang product. So, what I mean by that? Nangyayari yun sa tinatawag natin na activation energy. Yun nga, dito tema, this is where we talk about activation energy. Activation energy is the minimum energy necessary to form a product during a collision between the reactants. The interesting thing na I want you guys to remember is the higher the activation energy, meaning mas mataas yung energy na kailangan nila, requires a higher kinetic energy for the product to form, hence is lower rate. So we usually use a diagram to talk about activation energy, and it looks something like this. Okay. So this is time, and this is a measure of energy. Okay, so it usually looks something like this. Okay, if we are looking at our example here, dito yung reactants mo, and dito yung product. So reactant starts at an area with a higher energy compared dun sa product. Bago sila makarating sa product, they have to reach this area first. And yung difference between yung reactant, the difference between the reactant to the energy sa activation, the highest energy, ito yung tinatawag na activation energy. This is the activation energy. What that means is the reactant needs to go or needs to be able to reach that state of energy before they can form the product. Dito na nanggagaling yung kinetic energy, no? Kaya the higher the kinetic energy, mas mataas yung energy na gagawa nila as they collide, making them kind of like pushing them further and further pataas. And if the bumping has enough energy, it will finally reach them sa point na to, and then automatically pupunta na sila dun sa product. Because after reaching this state, kumbaga, nagro-roll ka ng bola, di ba? You can just release the ball and it will continue to roll down. Pero kapag nandito ka, hindi mo naman pwedeng kailangan mong itulak yung bola or kailangan mo siyang i-push. And that requires energy. Parang same concept, ganun lang yun. Pero at this state though, meron kang tinatawag na activated complex. So ano ba yung activated complex? This is kind of like a transition state ng mga molecules. So if we go from dun sa example natin, itong example na to, at this state, kumbaga, ang shape lang ng product mo is something like this. So you have C, and then you have, you have O. And then you have the oxygen. Yun yung mga shape nila as reactant. Pero pag as these two keep bumping, again, they have to bump hard enough and they have to bump in a proper orientation, meaning C needs to bump sa O. And if they manage to do that, they will finally achieve this activated complex or reach the enough activation energy to proceed to the product. Pero bago sila proceed sa product, they would assume a transition state. They would assume a shape that is not similar to the reactant and not even similar to the product. So at this state, kumbaga, ang pwede nila maging shape, let's erase this. So again, at this state, they would have a transition state called activation complex. Kumbaga, dito, ang pwede nila maging shape is something like this. Okay. So ito yung tinatawag natin na transition state. This is a theory on how products actually form. And itong transition state na to is napakadali lang, or parang napakabilis lang niya. It doesn't last very long. The reason for that is because it's in a higher energy state, and that is wasting a lot of energy. And nabanggit ko na dati sa inyo, everything in the world wants to be stable. At this state, they are unstable. Kaya mangyayari dahil unstable sila, ang gagawin niya, they would assume a shape wherein these two molecules can be stable. So dito na mangyayari na it will break this part. Therefore, after breaking that part, their energy status would become lower and more stable, creating na yung ating product. And this will need to bump into another O2, creating an O2. So parang ganun yung process ng um, ganun yung process ng product forming or ng reaction as visualized by activation energy. So I hope that is clear on how things are happening actually in the reaction process. And lastly, that sometimes that kapag sobrang steep no activation energy, so for example, if you have something like this, it will require, more energy to reach that top part in order for them to proceed into a transition state and finally go to the product. Sometimes sa sobrang taas niya, it is impossible almost for the reaction to form. There is a way to lower that, and ang ginagamit natin is catalyst. So catalyst can be used to increase the rate of reaction by lowering that activation energy. So if you guys remember, pinag-usapan na natin, catalyst is basically a substance that is used to increase the rate of reaction, pero hindi siya nakakonsume sa reaction. Ang ginagawa niya is actually lowering yung activation energy. So kumbaga, yun yung original activation energy mo. If you add a catalyst, bababa yung activation energy. And if that happens, mas madaling mag-perceive yung chemical reaction. Interesting thing then, remember, nag-umpisa ka at same and then you ended up at the same area. So it means you have the same reactants and you have the same product. So yun, ayun lang yun po. So you have your reactants and then it reaches this very high activation energy and then proceed. So that takes a little longer than if you lower the activation energy, and this time, mas mabilis na yung process ng reaction mo. Okay, so I hope that is clear. Dito walang catalyzed. Ito yung may catalyst. And again, same reactant, same product, kaya same area lang sila ng pinanggalingan at pinuntahan. And lastly, ang pag-usapan lang natin is there are actually two types of catalyst. One is called homogeneous catalyst, wherein homogeneous catalyst, for the homogeneous, yung meaning the same. This catalyst is present in the same phase as the reactant. So if you have two reactants that are both liquid, ang homogeneous mo is liquid. Ang gagawin ng catalyst na yun, it would actually interact with the substance, creating an intermediate substance. So this is similar to the activated complex. So gagawa sila ng shape, or they would form a molecular structure that nakasama yung catalyst. And nandun sila dun sa part na to, yung immediate, yung activated complex, yung structure, and then they would just decay to go to the product, and yung magdi-decay is matatanggalan yung catalyst. So just important thing na malaman nyo from the homogeneous catalyst is the word homogeneous, meaning it is the same phase. If your reactants are liquid, it is liquid. If your reactants are solid, it will be solid catalyst. And lastly, we have the heterogeneous catalyst. Heterogeneous meaning not the same catalyst, which is present in a different phase. So for example, if you have a liquid reactants, ang catalyst mo is solid. And napag-aralan natin yan, if you guys remember the Mentos and the Coke. Coke has a reactants of liquid, which is the soda, and then you have a carbon dioxide gas. And yung catalyst mo is na Mentos, which is solid. And ginagawa lang ng heterogeneous catalyst is it will help quicken the chemical reaction by hindi naman adding a surface area, pero there's something dun sa surface ng catalyst mo that will help the rate of the reaction. Pero yan, yung tandaan nyo na lang sa heterogeneous catalyst, since this is basic muna lang naman, is it is in a different phase than the reactants. So those are our catalysts, and that's our discussion for lesson 7.3. If it's confusing, please do not hesitate to message me. And thank you so much, and you guys have a great day.